Hi, today we're going to have a look at the section of your booklet that relates to angles of any magnitude. Once we've looked at the notes of this, that will allow us to go back and have a look at the exercise in our textbook 5E, and it's the heading is quadrant, sine and related acute angles. So we'll have a look at that in a moment once we go through some notes. Okay, so we're going to go on directly from last lesson, and where we were at last lesson was just looking at all stations to central. So remember the first quadrant, all our trig ratios were positive. The second one only sine. The third one only tan. And the last one was cos. So let's have a look up in the box up here. Now you actually already know all of these four sections of this table. I'm just going to talk us through it to remind you because you may see it written like this sometimes. Okay, if we have a look up here, this top one here relates to the second quadrant. And what it's telling us is actually the S part of our rule. It's saying here that sine is positive. So if you recall what happened in that second quadrant, we were looking at sine of 180 degrees minus theta, or minus our acute angle, and we said sine was positive, so that was equal to sine theta. Cos was 180 minus theta, and that was equal to minus cos theta, because cos was negative in that second quadrant along with tan. So that's just restating that second quadrant rule. We move on to the third quadrant, the one below it. It's just restating what we learnt last lesson as well. And we were always relating here to an angle theta, or our acute angle, that is 180 plus. So we're going around, we're 180 plus theta, but, oops, sorry, got to go all the way down there. But we're trying to find our acute angle. That third quadrant told us that tan was the angle that was positive. And that's what the rule here is saying. Okay, so sine of 180 degrees plus theta is equal to minus sine theta in that third quadrant. Cos 180 plus theta was equal to minus cos. And tan, because we were sine over the cos, became a positive. So tan 180 plus theta was positive in that quadrant. So again, you know that. We just need to remember that when we're in that second quadrant, we're taking our acute angle away from 180, where when we're in the third quadrant, we're adding that acute angle onto 180, or thinking of it in that manner. Now, the last one I want to have a look at over here is our fourth quadrant, and it's the C part. Oops. So of our all stations to central, it's our C. It tells us that cos is positive. And that's what the rule here is saying. Now, when we have an angle in that fourth quadrant, if you remember, I'll just pop one in there, okay? There's our acute angle there, but what's actually happening is we're going all the way around. Oops, I'm not having a good day with my diagrams there, am I? There we go. We're going all the way around until we meet our acute angle of theta. But what's actually happening is we're going 360, take away that theta. Is what's actually really happening in that fourth quadrant. So cos is positive in that quadrant. Sine and tan are going to be negative. So we're actually taking 360 minus our acute angle. Now, the other thing we can have a little look at are these little ones up here. Now, they really are the fourth quadrant as well. If you remember back to last lesson, we had a look at some of them. Actually, they're not always the fourth quadrant. We've only had a look at them in the fourth quadrant. So here we'd be starting and going backwards this way. So our theta is negative. So we're going in the negative direction. We'll have a look at an example in a minute where that theta that we're given in here isn't in the fourth quadrant. So we haven't had a look at one of those yet. So what that's saying is that sine of minus theta is going to be minus sine of theta. Okay, so over here our sine is negative. Cos of minus theta is equal to cos of theta. Okay, because cos is positive in that fourth quadrant, and tan of minus theta is minus tan of theta. Okay, let's have a look at some examples and see how we go. Okay, example 3, simplify. A says tan of 180 degrees plus x. X is the same as saying theta. They've just written that in a different format. So we know when we're 180 degrees plus x, we're going to be in the third quadrant. So you can draw yourself a diagram if you like for that. We're down here. So what we're saying is in that third quadrant, we are looking at our x or our theta there, and it is equal to positive tan of x or positive tan of theta. So I'm just going to write tan of x for that one. For B, cos of 180 degrees minus x. If we have a look where we are there, we're actually going to be in the second quadrant. And if we're looking at all stations to central, sine is positive in that quadrant. We're looking at cos, so our cos is going to be negative, and we're going to be negative cos of our angle here, which is called x. Okay, let's have a look down at question 4 down here. Now make sure you read the question really carefully. It says, if tan A is equal to P, express in terms of P this trig function here. Tan of 180 degrees plus A plus tan of 360 degrees plus A. Okay, so we're going to be relating that directly back to our 4 little rules, or our all stations to central. So I'm going to draw myself an all stations to central diagram. So that helps me out a lot. Get my pen to work. Okay, so here's my all stations to central over here. Okay, now let's look at the trig function. Tan of 180 plus A. I'm going to think, well, where is that going to sit in my diagram? Go back up and have a look in my diagram at the top. 180 plus theta was in our third quadrant. And if we think about what happens with tan there, tan is positive in that third quadrant. So we are going to be down here. Oops, excuse me, I'm having some pen dramas today. A lot of pen dramas today. Excuse me with that. Okay, so we're down there. So tan of 180 plus A is just going to be tan of A. Let's see what we're going to add to that. Tan of 360 plus A. Now that's a little bit different to what we've seen before. 360 plus A would mean we have gone around one whole revolution. And we've come back to where we've started and we've added on A. So that's just going to be tan of A. And all our trig functions are positive in that first quadrant. So what we have here again is another tan of A. So what we actually have is, if we think back to what the question said at the start, tan of A equals P. So we have a P plus a P, which is equal to 2P. Okay, let's have a look at question 5. It says, find the exact value of sine 45 plus sine 120. The key word in there is exact value. Okay, so when you're saying exact value, remember what you need to be thinking is you need to be thinking that we're using our exact value triangles, which what I've done over to the side for us, I've gone and snipped in green the exact value triangles from our formula sheet, from the HSC formula sheet. So we've got them there to have a look at. So you guys have got those and you can refer back to those. You've drawn them, you've got them on the OneNote, and you've got the HSC formula sheet in your books as well. Okay, so it says the exact value of sine 45. So let's go over to the top triangle with the 45 degrees in. Sine is opposite on hypotenuse, so we've got 1 over root 2 for that first one. You can just bear with me with my horrible computer today. 1 over root 2. Okay. Now, sine of 120. Okay, well, we don't have an exact value triangle for sine of 120, so we need to think, well, that needs to go back into our all stations to central rule and think, well, 120, where does that sit? That sits in our second quadrant. What was happening in our second quadrant with sine? Sine is positive. We know that, so it's going to stay positive. 120 is equal to 180 degrees minus 60. Okay, that's equal to our 120. So what we actually need here is sine of 160. Sorry, not sine of 160, is sine of 60. So we can work out an exact value for sine of 60 on our exact value triangles. We go to the bottom triangle. Sine is opposite on hypotenuse, so it's root 3 over 2. Now, we can do something to that. We can rationalise the root 2 at the start. So I'm going to times by root 2 and times by root 2. What we're going to end up with there is a root 2 over 2. I'm not going to go into that in detail. We've done the surds topic, so you'll need to make sure that you can get that. The second one stays the same because the bottom number is already rationalised. Our denominator is 2. So what our answer is going to be is root 2 plus root 3 over 2. Okay, this will now allow us to go into exercise 5E and have a look through there. There's some notes in there that you can have a look at. It's exactly the same as what we've just gone over, just in a little bit different format. I've sort of simplified what's in there into the notes. We know all stations to central. We know all our trig functions. I suggest you do what I did and we draw the diagrams. Draw our quadrants before you, while you're getting used to it. Pop your all stations to central in there and have a little look at. Now, something I wanted to have a look at right now was part B up here of example 10 that says sine of minus 210 degrees. We haven't looked at a negative that is bigger than 90 degrees before, so I thought that might be a nice one for you to have a look at. So remember the minus sign in there is telling us that the angle is going backwards. Instead of going in the direction of anti-clockwise, it's actually going to be going clockwise and going down from our first quadrant X coordinate line. So we're going to go around. 210 degrees will take us over the 180 degree mark, and it's going to take us 30 degrees over, okay, because we've got 180 degrees around to the negative X line here. If we have 30 more degrees added to that 180, we're going to hit the 210 mark. So we're in the second quadrant. We're looking at theta being 30 degrees. The question told us it was sine. If it's all stations to central, sine is positive in that quadrant. So what we've got is a positive sine 30, which we can use on our special triangles or our exact value triangles, whatever you would like to call them, and we end up with 1/2. I might have a look at the second one in there, the third one, C. We did one of these last lesson in the video and on the board, cos of 570. Now, we need to think about what is happening with cos of 570. So we know that 1 revolution is 360 degrees. So if I was to take 570, take away 360 degrees, I would end up with 210 degrees. So what's happening is I've gone around once to get to 360. I've gone around again to get to 210. In this case, I've gone to 180 and I've added on an extra 30 to get to my 210. So I'm not in the second quadrant like I was before. I'm now into the third quadrant with my acute angle of theta. So theta is 30 degrees. I was cos. Okay, so you're going to think, well, what's cos in my third quadrant? We've got all stations 2. Tan is positive, cos must be negative. I've got minus cos 30. I pop that in my special triangles that I've got minus root 3 on 2. So I want you to also look at the examples that are in here. These are really great. We've looked at those rules. You guys are ready at this point to go and have a go at 5E. The exercises I'd like you to have a go at in there, or the questions I would like you to have a go at, are in the work schedule in our OneNote. Make sure you can get down and have a look up to 10 and 11. I'd like to see you try and move on a little bit if you can have a look at the challenge ones in 12 to 15 if you can as well.